Welcome to Nucleus Analogs tutorial. This video will guide you through the process of filtering, scaling, and displaying your analog values. This video assumes you are running the Nucleus developer application and you have a project open. A digital value is represented as a value of 0 or 1. Analogs are defined as any I/O point that is not digital. Analogs represent numbers. An analog 16 represents a 16-bit integer. An analog 32 represents a 32-bit integer, and a single represents a floating point number. Singles are 32-bit fractional numbers. Singles do require more processing, so they should be used sparingly whenever possible. It should be noted that some PLC systems define singles as the real data type. Let's open the analog window as we continue the tutorial. Analog values in process control can fluctuate considerably. Examples are position sensors, temperature sensors, voltage sensors, and level sensors. Since these analog values are calculated via instrumentation, the least significant bits in the pattern will often shift rapidly. Therefore, the resulting number representation is constantly changing as well. If your control system uses a lot of fluctuating analog values, the constant changes can slow down your control system. Part of this slowdown occurs via the communications, the updating of your screens, and the recording of historical values for reporting and playback to screen. So to lessen the impact, the Nucleus developer allows you to filter and scale your analog values. Every defined indication that is an analog value will automatically be shown in this list. So you don't have to add or remove anything. Notice the two columns on the right named Update and Store. You can edit these values directly in the list. Let's filter this list by the source of MB2. This is our test Modbus link using fractional values, and the protocol data type was set as single. At the top of the list should be the unnamed tagged ATAG001. At the default creation, D tags are digital and A tags are analog. Notice that the default value of all analog values is 0 for the two columns. A value of 0 means there is no filtering applied. The update column defines how often the screens are allowed to update. If you make the value 3 in this column, it represents 3 changes. This is how many changes in this value need to occur before the control system will evaluate or display that value. The store column is for historical recording. If you have a value that is changing very rapidly and you don't want it recorded in history every time it changes, then open the indications window and set log to false. However, if you do want the value to log in history, keep the indication log set to true and slow down the recording in history. To do this, we will set the store column to 5 and save our changes. Therefore, only 1 out of every 5 changes will be stored in the historical database. Now, the ATAG001 indication will only display once every 3 changes and record once every 5 changes. This filtering will slightly improve the HMI station performance and reduce the number of indications stored in history. The multiplier column is for scaling. Select the source as MB2 and select the unnamed tag ATAG033. Now select the multiplier button. Let's say that the PLC is sending this value to our communications server with a range of 4 to 20, but we want to display this in a bar graph as a value of 0 to 100%. To make the conversion, we enter the raw values from the PLC as 4 and 20. Then we enter the desired values from 0 to 100. Now we select the Calculate button to see the multiplier. As you can see, this gives us a multiplier factor of 6.25. Now to test this, we know that a value of 12 is halfway between 4 and 20. So if we enter the value of 12 in our test box, we should see the value of 50 because it is halfway between 0 and 100. And we do see 50. If we try to test a number that is below 4, then the developer will alert us to the invalid entry. In a running system, the value would display negative if under 4. But this should never happen if the PLC is programmed correctly. Now, let's save the changes. The multiplier now displays in the analog window. For the remainder of this tutorial, we will move to the display creator so we can add some icons and graphs and test our values. Open the analog screen we have added for this demonstration. Here we have placed a number of analog display icons for the screen. The reason for shifting these icons to the left will become clear as the tutorial advances. The first column is just text displays, set to the colors we wish to present in our tutorial. The second column has the analog input box. As we have noted before, your indication and control name must be the same to use this icon correctly, and you must set each control to latch to make this work. The third column is simply the analog box for display only. We have set the display format differently on these to show versatility. And of course, you could use expressions to change text or background colors based on limits if you wish. If you recall, we did this on the shipping screen example in a previous video. The fourth row contains the arc gauge. You can use this alone or place a template image underneath as we have done in the third row. Some people mistake the gauge images as working gauges, but they are just static pictures. The only gauges are the dynamic arc and bar gauge graphic types. And the last column shows several examples of the bar gauge. You can place this icon on a tank or on top of another picture to show the level or temperature of a processed product. You can even rotate it sideways to show progress if you wish. It all depends on how the PLC determines what the value represents. Notice that in the last column we placed a gauge image underneath the bar gauge to make it look a little bit more sophisticated. And this next example will disclose a little trick with the graphs at the bottom. Each graph icon only allows one analog value assignment and one pen color. However, if you set the background color of the graph to transparent, you can stack them on top of each other. This allows you to show multiple analog values within the graphs with very little configuration. This was an elegant method for simplifying the graph tool for you. Watch as we move them away from each other and use the align tools to layer them on top of each other again. Now we will run the HMI station and the simulator. We created a script in advance that we can run to see the value changes on the HMI. Be sure to never run the communication server with the simulator, as the communications will overwrite your simulated values. Note that we can't test the delay logic with the simulator because it does not continuously check timestamps when updating values. So please watch carefully as we demonstrate the display icons and the multiplier functions as we discussed earlier in the tutorial. This completes the tutorial on Nucleus analogs. Be sure to consult the Help Center for more information. And if there is anything you need help with, create a new ticket via your customer portal and we would be happy to assist.